A 15 kilogram object initially traveling at a constant speed of 1.75 meters per second. So initially we have a constant speed, which means we start off by not having an acceleration, which means we start off by not having a net force acting on us. But then we start accelerating, right? Then we start accelerating at a rate of 2.8 meters per second squared for 12 seconds. So yeah, then we get a force acting on us. What they want to know is, what is the magnitude of the object's velocity at the end of this 12-second interval? Well, if we're talking about beginning and end, we have initial and final. VI, they told us, the initial velocity before we started accelerating was 1.75 meters per second. And they want to know what the final velocity is. They gave us time. They said time is 12 seconds. And actually, let me put 0.0. 12.0 seconds, and they said the acceleration is 2.8 meters per second squared. And what we also know is we have the formula VF equals VI plus A times T. Well, we want VF, so 1.75 meters per second for VI, we plug in everything in, times 2.8 meters per second squared times 12 seconds. And then we do 2.8 times 12. Let's find that out first. 12 times 2.8. And this is going to give you 33.6 seconds. Actually, that's not a unit. Plus 1.75. So 33.6 plus 1.75. You wind up getting 35.35 meters per second for the final velocity. And now the second part says, determine the magnitude of the net force that caused this acceleration. Well, we know net force, F net, is equal to mass times acceleration. They gave us our mass. They said it was 15 kilograms. And they gave us our acceleration. They said that that is 2.8 meters per second squared. So we want to find that net force that's making this thing accelerate. And all we do, plug in those values. 15.0 kilograms times 2.8 meters per second squared. Let's find out what that is. 2.8 times 15. You get 42. 42, whoops. The unit on that, remember, force is newtons. So F net equals 42 newtons.